So in today's video, we'll be talking about rate limiters and how they work and where we should use them. The main functionality of a rate limiter should be to limit the amount of requests a user can make to a server. For example, as you can see in this image, if a client is sending requests to a server, we can add a rate limiter in between to limit the amount of requests it can make within a short amount of time. This mechanism of rate limiter will ensure user will consume politely our servers. One of the rules can be a user can make not more than 10 requests per second. In this video, we'll be making something simple. Our role is to make 10 requests per minute. So we should not be able to send 15 requests within just a minute. So there are many algorithms we can use to make our rate limiter, but one of the common algorithms is called token bucket. I don't remember how is it called. I think token bucket, but this is the mechanism of the token bucket algorithm. So initially, every user will have some amount of tokens. For example, in this case, let's say that the user have 5 tokens. Every time the user will make a request, we'll check if there are enough token. If so, we'll subtract 1 token and then pass the request to the server. Otherwise, we will just drop the request. If the user keeps sending requests, at some point, the token available will be 0. So there will be another mechanism of refilling. That mechanism will be respecting our rule, which is in our case, every minute it should just fill 5 more tokens. In order to make our rate limiter work, we will need something called cache. A cache memory, and in our case we'll be using a Redis, because in this cache we'll be saving the user information and the amount of token a user has available, and also, for example, other information such as the last request he has sent. You might ask, why don't we use a database for this? Why do we need a cache memory instead of a database? Just for the simple reason, because cache memories are faster than databases. So as I said, in our cache memory, we'll be saving the user information and the amount of token it has left. Now the question is, how can we identify a request? There are many ways to identify a request, but to make it simple, in this video, we'll be using API keys. So to get access to our database or a server, you will need an API key. So every user will have a different API key, and every request will have API key in the header, so we can check the header to see which user is sending that request in order for us to save that information. So let me explain one more time what are we going to do in this video. We will create a rate limiter. First of all, we will create a simple API, and also we'll be creating this rate limiter. And the role of our rate limiter will be a user can only send 5 requests per minute. If a user is sending more than 5 requests within a minute, the user will not be able to consume our API, and we'll be using Redis as caching memory. So now we can open VS Code and start building the project. So we'll start the project, npm init. So npm install nodemon express and io Redis. Okay, the libraries are installed. Now we can start our project. So this is our simple API. So we have 2 routes. One is home and one is API resources. And also we'll be listening to support 3000. So let's test this API and see how it goes. Before that, let me change the script here, call it dev. So I can say nodemon index.js. Start it. npm run dev. Okay, it is running on port 3000. And now we can test our API through Postmon. Let's make a request. And we see this. API resource accessed successfully. And as you know, we didn't implement our rate limiter, so we can call this API whenever we want and we will receive. So this API is not respecting our role. That's why we need to implement our rate limiter to limit the number of requests we are sending to the server. So let's get back to VS Code. So here we need a middleware, and it will be like this. So every request will go to the middleware before going to the endpoint, one of these 2 endpoints, and then the endpoint will send a response. And this is how to use a middleware in Express. So you just say app.use and then put a callback function. And inside this function, we'll be having 3 arguments. We have request, response, and also next. So as you can see, for every route, we'll be having the same function, request and response, but here we have next, because this next is just another callback function, which is one of the endpoints. So this is our middleware, our rate limiter middleware, and here we'll be putting our logic inside. Before that, let's create another file, call it rate limiter. Here we'll be creating a class called rate limiter. So basically, every time we will create an instance of this rate limiter class, we have to pass these values. First of all, the Redis client, the key prefix, which is just the bucket name. We have also token per minute, which is the amount of token we have to fill the bucket every minute. We have also bucket capacity and token required. This token required is the amount of token we need to be able to make calls to our servers. If you have less than one token, we will not be able to make call to our servers. Then we'll need a method called getBucket. After that, we'll have also another method called allowRequest. Passing the ID to allowRequest, we can know if we should allow the request or not. Because as I said, knowing the client ID, we can get the bucket key simply by doing this. And knowing the bucket key, we can get the values, the information of that client ID. Here we will continue with our logics, and we should export the rate limiter. Now let's get back to our index.js. First of all, we import the Redis module, and then let's also import the rate limiter module that we just created. Then we will declare our Redis URL. So by default, the Redis URL should be this in your local machine. So it will be on localhost on port 6379. So now we can create the client. So we just say const redis equal new Redis, which is this thing, and then pass the URL. Now we can start an instance of that class rate limiter. So we say const rate limiter equal new rate limiter, and then pass value. So we see that first of all we have to pass the client, so which is Redis, and then we have to pass the key prefix, let's say API or rate limiter or something like that. Then we have token per minute. As we said, we should have, for example, 5 tokens per minute, so 5 requests per minute. And then we have bucket capacity, which is in our case 5 too, and also the token required, which is 1. So I'll be saving those values inside here, these variables, because we will be using these variables later on. Okay, now that we have our rate limiter, we can use it in our middleware. So first of all, we need the client ID, which I said is just the API key, and we will take it from the header of the request, because we can identify the user of that request through the API key. So having the client ID, we should use the rate limiter object to check if that request is allowed or not. Because as we see here in our class, we have a method called allowRequest, which is also a synchronous function. We'll go later to do the logic here, but keep in mind this should return a boolean true or false. So if this variable allowed is true, we should go next. So otherwise, if it is not allowed, we should just send a response to the client saying rate limit exceeded. And this response should have a status code of 421. And inside the response also we have these different headers: x rate limit, which is the amount of limit. These information are very important to send back to the client, because from there we can tell the user what is the problem. This is the remaining token it has, or the remaining request, and also the amount of time it should wait to send the request. This rate limit retrieve after should be 1 minute, so which is 60. Okay, so this is our middleware. It is done, but we have to make sure this function is returning. So this is our middleware of rate limiter to limit the rate, and we should just make sure this method is working as it's supposed to be. So let's go there and try to make the logic. So first of all, as we said, we need the client ID to get the bucket key, and for every request we should also see the current time of that request. This is very important for us because it will allow us to know if we should add tokens or not. And what we're trying to do here is using hash map and trying to get the bucket key, these values of the bucket key, the tokens available, and the last time it was refilled. And also we'll set an expire. This is very important in Redis, because when we set a variable, we can set also the time to live of that variable. So while fetching data from our store, we'll get the value of the last time our bucket was refilled, and also the amount of tokens available inside our bucket. But mind that if we try to get these values of a bucket that doesn't exist for the first time, these values will be null. So that's why we will need to check if the last time we refilled it gives us a value and we parse it, it's okay. Otherwise, the last time should be the current time, which is the time where we made the request. Same thing with available tokens. We'll try to see if the token is different from 0, which is a string. We'll just parse it. Otherwise, we'll just say it will be the bucket capacity. So now this is very important. So we're trying to see the time passed from the last refilled. So we subtract the current request time. The current time, as I said, it was when we just made the call. And then we're trying to subtract it to the last refill. So if it was for the first time, last refill would be current times, so time passed will be 0. Otherwise, if the last refill was time ago, so we passed it like here, and then we subtract it, it will give us a value. And that is the time passed. And then we can calculate how many tokens we have to add. Bear in mind, this subtraction will give us a value that is a decimal number. And for example, if 1 minute has passed, this operation will be equal to 1. Otherwise, if it was 30 seconds past, this operation will be 0.5. So it just depends the amount of time that has passed, expressed in minutes. That's why we say time passed times token per minute. If the time passed is 0.5 times the token per minute times 5, we'll have 2.5. So the token to be added, since we are passing it in integer, the token to be added would be 2. Let's say that the last time the user made a call was 5 minutes ago. So the difference will be 5 minutes. So in this case, for example, this will result to 25 because time passed is 5 and also token per minute is 5. So 5 times 5 is 25. So tokens to add would be 25. That's why, for example, here we have a new token that will just take the minimum value between the bucket capacity. Bucket capacity, we know that it is 5. And available, if this surpasses 5, we'll always have new token as 5. The maximum we can have here is 5. Otherwise, for example, let's say this is 0.5. So you multiply 0.5 times 5, we will have 2.5. So the token to be added, since it is passed in integer, it will be 2. And the new token, which is the minimum between 5 and 2, so it will be 2. And once we have the new tokens, now we can make the logic to return true or false. If the new token surpasses the token required or equal to the token required, for example, if you made the calculation and we see that new token equals 0, so this would be false because 0 is not higher than token required, because token required is 1, so we should have 1 in order to allow the request. Otherwise, without tokens, the user is not allowed to make a request. So if the new token is greater or equal to token required, we should just update this information of that bucket key. We will return true and it will consume our API.